Module 7, problem number 11. Determine if there is a linear relationship among air temperature x1, wind speed x2, and wind chill y. The following data show the measured values for various days. So here we have the data set. As you can see here, I already opened it up in StatCrunch. So let's go ahead and look at part A. Find the least squares regression equation. Y hat equals B naught plus B1 x1 plus B2 x2, where x1 is air temperature and x2 is wind speed, and y is the response variable, wind chill. So similarly to last week, we're looking at an intercept and a coefficient. In this case, we just have two coefficients since we have two predictor variables. So let's go ahead and look to StatCrunch. Again, I just clicked on this button to open in StatCrunch. As you see here, we have x1, which is our air temperature, x2, which is wind speed, and then y, which is going to be wind chill. So to find our linear regression line, we're going to go to Stat, Regression. Now last week we went to simple linear because we only had one predictor variable. Now that we have multiple, in this case 2, we're going to go to multiple linear. We're going to select our y variable, our response, and our two predictor variables, x1 and x2. Now, I'm going to scroll down and show you something that's going to help you for part B. I received a question about this. So we're looking for in part B, you're going to be looking to plot your residuals against each of the predictor variables. So in this case, we're going to select residuals and save it. That's going to add another column to our data set with just those residuals. So click compute. Here's our results, and we'll talk about those residuals in a minute, but let's look at our results for part A. So we have our regression line here, and then we also have the numeric values here. So here we have our intercept and then the coefficients for x1 and x2. So y hat equals, our intercept is negative 12.509. Our x1 coefficient is 1.334, and our x2 coefficient is negative 0.414. Let's check answer. Excellent. Part B, like I was just talking about with the residuals, draw residual plots to assess the adequacy of the model. Create the residual plot for air temperature. Choose the correct graph below. Remember last week, one of the things that we talked about is if your residual plot shows some sort of discernible pattern, that means that your linear model may not be appropriate. So let's go back to our StatCrunch. Here's that residuals column that I was mentioning before. So remember, your residuals are the difference between your predicted value, y, and your, y hat, and your actual value, y. So we're looking basically, it's a measure of how far off is our predicted value from what we observed in the data set. So to plot those residuals, we're going to go to Graph, Scatterplot. Now, remember, in this one, we're looking at air temperature for this first part in part B. So we're looking at x1 as our air temperature variable. Our y variable, don't be confused, we want the y-axis in this case to actually be our residuals, not the y value. Now, again, there's a lot of options down here for how you can change the graph or make it look different. We're just going to stick with the basic options here so I can show you how to compare it to the options available here. So click compute. So let's take a look. As you can see, it's kind of scattered all over the place. Here we have negative 15 up to 15. So let's see down here. We can see at least a couple down here with negative 15, where we have this value right here is above 1. So we know this needs to be a positive value on the y-axis right here when you have negative 15 here. So I'm kind of seeing what looks like maybe negative 15, something right here. This looks like a very similar overall pattern, and we can see here, there's 3 data points here. I want to point out something. This is a very small graph. So if we wanted to blow this up a little bit to see, as you see, so you can click on you can either zoom in, but I'll warn you against that. You can't easily zoom back out because that option kind of disappears when you start zooming in, or you can pop it up. So now just looking at it, we see that the lowest value here is around -1, maybe -2. And we see a similar pattern to what we think here. This clearly does not match that pattern because you see here everything's below 0 on the y-axis, whereas here we have values up here above 0, positive values. Here you have nothing that's negative, whereas here we see some stuff that's negative. Again, here you see everything is at 0 and above on the x-axis, whereas we see here negative values. So we can kind of tell from that it's probably going to be D. But let's go ahead and pop it open and take a quick closer look. See, one thing that was a little bit confusing is that we see 2 data points very close together here. On the little itty bitty graph, it looked like there was only 1 here. Now we can see here after we've opened it up that there's 2 here, 3 total on that negative 15 value. So overall, we can see that this is the graph that best matches our residual graph here. So let's go ahead and click on D. Check answer. Well done. All right, let's do the second part of part B. Create the residual plot for wind speed. So let's go back to StatCrunch, and we're going to go to Graph, Scatterplot, just like we just did. It's exact same thing, except this time we're looking at x2, which is our variable for wind speed. Again, our y variable in this case is the residual. Compute. Now, let's look at the patterns here. Just looking at the pattern, I can see that this is it. You can see a slight U-shaped, or not parabola pattern, but that U-shaped pattern here. You see it here. We clearly don't see a straight line. We clearly don't see this on this plot, and we clearly don't see this. So let's go ahead and choose C because we see that same U-shaped pattern. Check answer. Nice work. There we go. Now, for the last part here, it says, what might you conclude based on the plot of residuals against wind speed? Choose the correct answer below. Now, what we just talked about when we were comparing them, we do see a discernible pattern. It's like a U-shaped pattern. It is not a random plot. So we can already take out A and B because it shows that there's no discernible pattern. Now, what we also just talked about was that when the residual plot shows a discernible pattern, the linear model is not appropriate. So as we can see here, that's option D. Check answer. Nice work. All right, that's it for problem number 11. If anyone has any questions about that or anything else, let me know.